So today we're going to discuss 45, 45, 90 triangles. These are called a form of special right triangles. So we've already talked about right triangles, done lots of triangles actually, the ones that even aren't right triangles. And we've done the Pythagorean theorem. So in a 45, 45, 90 triangle, you all know what it looks like. It has a right angle, and the other two angles are 45 and 45. Now the Pythagorean theorem talks about the legs and the hypotenuse, which we already talked about. Okay, now a pattern that you may have noticed when there are 45, 45, 90 triangles is we have the leg over here, which is L, and we have the leg over here, which is L. And if you noticed, to get the hypotenuse, we take the leg and we multiply by the square root of 2. So let's write this out. The hypotenuse equals the leg times the square root of 2. Okay, so let's take a look at some examples of how this can work. Okay, so let's try our first example here. Okay, so we're going to have a triangle, and it's a right triangle, 45, 45. Now, if you remember one of our triangle theorems, we know that the angle opposite is going to have a certain measure, and if there are two angles that are the same, that the sides opposite will have the same measure. So let's call this X. Let's call this side Y. And 9. So our legs are X and 9, and our hypotenuse is Y. So from our angle theorems, if we're going to find X, if these two angles are the same, then these two legs must be the same. So X is going to be 9. And in order to find Y, we know from what we just talked about that the hypotenuse is the leg times the square root of 2. So Y is going to be the leg, 9, times the square root of 2. Okay, that's a pretty simple example. Let's move to maybe a little bit more complicated one. Okay, so in this example, let's say we have our triangle, 45, 45, 90 triangle. So let's say our hypotenuse is X, our leg is Y, and this other leg is 2 times the square root of 2. Okay, so we already talked about how the legs are going to be the same. So that makes Y 2 radical 2. All right, now let's figure out X. Okay, so X is going to be the leg, 2 square roots of 2 times the square root of 2. Okay, so let's simplify this here. So we're going to have 2 times the square root of 4, because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So we're going to have 2 times 2, so X equals 4. Okay, so let's look at one more example. This is going to be a little bit more complicated again. Okay. So our example this time, have another triangle, right triangle, 45, 45. Okay, so this time I have a leg, it's going to be X, but this time I know the hypotenuse, which is 6. So I'm going to use the information about the hypotenuse to find out how long this leg is. And do we really care about this leg? Not so much, because we know that these two legs are the same measure. Okay, so we're going to take the hypotenuse equals the leg times the square root of 2. So the leg times the square root of 2 equals the hypotenuse. The hypotenuse equals the leg times the square root of 2. Okay, now we have to get X by itself. So we're going to divide by the square root of 2. So x equals 6 divided by the square root of 2. Now, can we leave radicals as a denominator? No, we cannot. I'll move this up just a little bit. So we got to do some algebra here. So we're going to multiply by the square root of 2 over the square root of 2. Okay, what did we just multiply by? We just multiplied by 1. Okay, so we're going to say this equals 6 times the square root of 2 is 6 square roots of 2. The square root of 2 times the square root of 2 is the square root of 4. The square root of 4 is 2. Okay, 6 and 2 can be divided. So 6 divided by 2 is 3. So we have 3 square roots of 2. So we know that x equals 3 square roots of 2.